So today we're going to talk about power series. And this is not a short section. So I would divide it into two parts. And today we will only do the first part. So a power series is an infinite sum of a form like this. This is a power series, and or you could have a power series with x minus a to the power n, where n goes from 0 to infinity. It should be 0 to infinity. It depends on the consideration. So a typical example would be the geometric series. And you can see that in this case, all the an would be equal to 0, would be equal to 1. And we know that this geometric series converges when x is less than 1. And in this case, the sum is actually known. In this form. Another example is x to the power n factorial. So this is 1 plus x squared divided by 2 factorial, x to the power 3 factorial, etc. And this one, when we consider using the ratio test, then the an plus 1, well, the an should not be, let me use a different notation. Let me use capital N. So here capital N stands for x to the n over n factorial. So xn plus 1 divided by xn would be equal to xn plus 1 divided by n plus 1 factorial divided by x to the power n factorial. And this can be easily simplified to x over n plus 1. If you take a modulus sign, and you can see that it goes to 0 as n goes to infinity for each fixed x. And because of that, this series that we are considering converges for all x. And by that we mean any fixed x that you choose, the series will converge. And so that we say that it converges for every x. Of course, for a different x with a smaller size or bigger size, then the actual series, how it converges, would be different. But as far as convergence is concerned, they all converge. All right, here is another example. So maybe I should list them as example. And here is another example. And then the third example would be to consider f to be in this form. So this is also a power series with the coefficient, which is a power of 2 to the power n divided by 3 to the power n, and you can start from n equal to 0 to infinity. So in this case, to investigate whether this series will converge, you can use a ratio test, but this time we choose to use root test. And by that, we're going to have 2 to the n over 3 to the n, x to the power n. So we want to look at taking the nth root. So in this case, it's just easy to see, we end up with this quantity. And we want that to be, so the principle for the root test would be after you take the limit, and here is also you take the limit, you want the limit to be less than 1, right? So this is the case if you restrict x to be less than, the modulus of x to be less than 3/2. In other words, you want to restrict x to be 3/2 minus 3/2 to 3/2. So comparing to the last example, if you draw axis, this is 0, then everything that you pick on the real axis, so this is a real axis, the series converges. Whereas in the second example, you could see, so this is 0, this is minus 3/2, this is 3/2, so the place in which the series converges is this interval as indicated. And you can slightly twist the example a little by considering the same series, same coefficient, but with, let's say, x minus 2 to the power n, where n goes from 0 to infinity. So this looks like the last one, but x is shifted by 2 to the right. So you can apply the root test or the ratio test to see where it converges. But here we use a different trick. We take capital X to be x minus 2. If that's the case, then the series would become 2 to the n over 3 to n, and capital X to the power n, where n still goes from 0 to infinity. So if you look at this example and compare this with the earlier example that we just considered, then this would imply capital X is within 3/2 for this series to converge. So that translates back, when it translates back to little x, then you would have the little x minus 2 is less than 3/2. Or you take away the absolute value sign, then you would get the following. And so this can still further be rewritten into the form after removing the 2. You add 2 on both sides, so this essentially means that you would have 4 minus 3, so this is a half, and this is, you're adding 4 to it, so 7/2. So this is between a half and 7/2. So if you draw this picture on the real axis, let's say this is a half, this is 7/2. So then the series would converge. So this is the x-axis, right? In this part. Okay, so with this background, we could now introduce the idea